Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar. And you welcome back to this study. Dear student, in this first video lecture of week 5th for the course Applied Mathematics 1, today we are going to learn about derivative of a function. Dear student, first of all, I would like to tell you the geometrical meaning of derivative. Let A is a point and this A be a fixed point and P is another point and this P be a variable point on the curve of the function f of x as shown in the figure, and you will see the figure on next coming page. The slope of the line AP is given by y minus y naught divided by x minus x naught, or f of x minus f of x naught divided by x minus x naught. We can write f of x is equal to y and f of x naught is equal to y naught. When the variable point P move closer and closer to along the curve f of x, that is x tends to x naught, the line AP becomes the tangent line of the curve at the point A. Hence, the slope of the tangent line at the point A is equal to limit x tends to x naught f of x minus f of x naught divided by x minus x naught. This term is defined to be derivative of the function f of x at x is equal to x naught and usually denoted by f prime at x naught. So dear students, you see over here, this is the geometrical diagram of derivative. This is the curve of the given function y is equal to f of x, and this is the fixed point A, and this is the variable point P, and this AP line is the tangent line. So you see over here, we have already discussed in this slide that when the variable point closure move closer and closer to along the curve f of x, that is x tends to x naught, the line AP become the tangent line of the curve at the point A. Hence, the slope of the tangent line at this point A is equal to limit x tends to x naught f of x minus f of x naught divided by x minus x naught. This is actually the derivative of the function at x is equal to x naught. Now, the definition of derivative at any point may be defined as: let y is a function, y is equal to f of x be a function defined on the interval, on the closed interval AB, and x naught is a point belong to the open interval AB, then the function f of x is said to be differentiable at x naught if the limit x tends to x naught f of x minus f of x naught divided by x minus x naught exists. This limiting value is denoted by f prime at x naught, or derivative of y with respect to x at x is equal to x naught, and is called the derivative of the function at x is equal to x naught. If the function has a derivative at every point x in the interval, in this open interval AB, then the function f of x is said to be differentiable on the closed interval AB. So dear students, this is actually called the derivative by definition of a function at x is equal to x naught. As x tends to x naught, the difference between x and x naught is very small, that is x tends to x naught tends to 0. Usually this difference is denoted by h or delta x. Then the derivative at x naught may be written as limit h tends to x 0 f of x plus h minus f of x divided by h, and this is known as first principle method. This formula is called the derivative by definition or derivative by first principle. So dear students, if we calculate the derivative of a function at some point x is equal to x naught, then we can use this formula, and this is called the derivative by definition. So derivative of a function at x is equal to x naught, by using the definition mean we use this formula, limit h tends to 0, f of x plus h minus f of x divided by h. So first of all we find f of x plus h, and then we put the function value f of x and f of x plus h, and subtract f of x from the f of x plus h divided by h. But first of all we check whether the function is differentiable and this limit h tends to 0, because sometime we obtain 0 by 0 form. So 0 by 0 form is actually undefined form. So we will try to define the derivative of the function, then the function will be called differentiable function. So dear students, now for example we have an example of a function f of x is equal to x square plus 1, and we want to obtain the derivative of this function by using the definition. So by using definition, the derivative formula is given by f prime at x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. So dear students, putting in this formula the value of f of x, this is the value of f of x, x square plus 1, and this is the value of f of x plus h. Now replace this x by x plus h, we obtain x plus h whole square plus 1. Now putting these two values, f of x and f of x plus h, in this above formula, we obtain the derivative of the function is equal to limit h tends to 0, x plus h whole square plus 1 minus into x square plus 1 divided by h. Now dear student, if we put limit h tends to 0 in this expressions, we obtain h0, x square plus 1 minus x square plus 1 will be cancelled, so 0 divided by 0. So this is actually the undefined form. Now we are going to define this expression. So to define this expression, first of all simplify this expression, then put the limit h tends to 0. So x square x plus h whole square mean x square plus h square plus 2xh, and this plus 1 is it is, and minus into x square plus 1. Now x square plus h square plus 2xh plus 1 minus x square minus 1. Now minus x square and plus x square cancel, and plus 1 minus 1 cancel, we obtain h square plus 2xh divided by h. In these two terms, here h is the common. Now you see over here, f prime at x is equal to limit h tends to 0, h square plus 2xh divided by h. Now taking common h from these two terms, h into h plus 2x divided by h, at h and h cancel, so we obtain f prime at x is equal to limit h tends to 0 into h plus 2x. So putting the limit value, limit h tends to 0, we obtain the derivative of the function is equal to 2x. So dear students, note that if we want to calculate the derivative of a function by using definition, then use this formula. This is actually the derivative by definition formula. In this formula you see over here, we will put two values. One value will be the given function which is already given in the question, f of x. Put the value of f of x and obtain f of x plus h from the given function. How we can obtain f of x plus h from the given function? This is very easy. Replace x by x plus h in the given function. You will easily obtain f of x plus h. You see over here, this is the f of x value. F of x value is defined as x square plus 1. Now for the function f of x plus h, you see over here, just replace x by x plus h in the given function. You will obtain f of x plus h is equal to replace this x by x plus h whole square, and plus 1 as it is. So from the given function you can easily obtain the function f of x plus h, and f of x is already given, so putting these two value in the in this formula, and then simplify the function to define the undefined limit. This limit will be undefined because you see over here, if we put h is equal to 0 in this formula, we obtain f of x minus f of x. F of x and f of x cancel, so in numerator we obtain 0, and the denominator h is 0, so 0 by 0 is undefined. So dear student, note that actually this limit will be undefined, but we will try to define the limit, because we discussed already in the definition that this is the derivative of the function. If limit exists, then the function will be differentiable. Now another formula, another problem you see over here, to use the definition of the derivative to calculate the derivative of the function f of x is equal to under root x. So dear student, first of all, put the formula of the derivative by definition. F prime at x mean derivative of the function with respect to x, which is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So you just put these two terms in this formula, put the value of f of x which is given, and first of all obtain the value of f of x from the given function f of x. Replace this x by x plus h, you can easily obtain the value of f of x plus h. Like you see over here, this is the value of f of x plus h. Replace x in the given function by x plus h, you obtain under root x plus h. So putting these two values, putting the values of f of x and f of x plus h in this formula, in the given formula, the formula is f prime at x is equal to limit h tends to 0 f of x plus h. This is the value of f of x plus h, you see over here, and this is the value of f of x divided by h. Now if we put the limit h tends to 0 in this formula, if we put h is equal to 0 in this expression, we obtain under root x minus under root x, which is 0, and divided by 0. So 0 by 0 form mean this is undefined. Now we are going to define this limit. To define this limit, we take the conjugate. We can divide and multiplying this expression by under root x plus h plus under root x. When you see over here, f prime at x, the derivative of the function at x is equal to limit h tends to 0 under root x plus h minus under root x divided by h. Now dividing multiplying by the conjugate, under root x plus h plus under root x divided by under root x plus h plus under root x. Now to multiply the numerator, to multiply the numerator, we use the formula a minus b into a plus b, which is equal to a square minus b square. So under root x plus h whole square minus under root x whole square divided by, and the product of denominator is you see over here, h into under root x plus h plus under root x. Now under root and square cancel, under root and square cancel. You see over here in this slide that our derivative of the function at x is equal to limit x tends to 0 is equal to limit x tends to 0 x plus h minus x divided by h into under root x plus h plus under root x. Minus x and plus x cancel, we obtain limit h tends to 0 h divided by h into under root x plus h plus under root x, and this h and h cancel. Now we put the limit h tends to 0 for the expression 1 over under root x plus h plus under root x. So putting limit h tends to 0, we obtain 1 over under root x plus under root x. Under root x plus under root x will be equal to 2 under root x. So the derivative of the given function is equal to 1 over 2 under root x. Now another problem, by using the definition of derivative to calculate the derivative of the function 2x divided by 1 minus x. So this is the uh, formula of derivative by definition. Derivative of the function is equal to limit h tends to 0 f of x plus h minus f of x divided by h. So first of all, obtain the value of f of x plus h from the given function. In the given function, just replace x by x plus h. You can easily obtain the value of x plus h. So replace this x by x plus h. You see over here f of x plus h is equal to 2 as it is, and replace this x by x plus h divided by 1 as it is, minus as it is, and replace x by x plus h. So this is the value of f of x plus h, and the value of f of x is already given in the problem. So putting these two values in this formula, you see over here derivative of the function is equal to limit h tends to 0. This is the value of f of x plus h, you see over here, minus this is the value of f of x, and divide by h. Divide by h, you see over here 1 over h. Now derivative of the function is equal to limit h tends to 0 1 over h. Taking the LCM of this expression, we obtained 1 minus x into 2x plus 2h minus 2x into 1 minus x minus h. For the LCM, multiplied the denominator two terms, you see over here. Now multiplied this term with this term, and multiplied this term with this term, simple by cross multiplication. So multiplied this term 2x plus h multiplied with 1 minus x, and multiplied 2x with 1 minus x minus h. You see over here, this is the LCM of this expression. For the LCM, first of all, we multiplied these two denominator term, and then divide this expression 1 minus x into 1 minus x minus h. Divide this expression by 1 minus x minus h. We obtained 1 minus x. So multiplied 1 minus x with this term, and similarly for the next term, divide this result by 1 minus x. We obtained 1 minus x minus h. That's why we multiplied 1 minus x minus h with 2x. In other wording, you can easily take the LCM by using this procedure. First of all, multiplied the denominator, and then by cross multiplication, multiplied this term with this, and multiplied this term with this. You can obtain the LCM 1 minus x into 2x plus 2h minus 2x into 1 minus x minus h divided by 1 minus x into 1 minus x minus h. Now multiplied these two terms and multiplied these two terms, you see over here we obtained the derivative of the function limit h tends to 0 1 over h into 2x plus 2h minus 2x square minus 2xh minus 2x plus 2x square plus 2xh. Plus 2xh and minus 2xh cancel, minus 2x square plus 2x square cancel, 2x and 2x cancel. We obtain only one term in the numerator. Like you see over here, the derivative of the function is equal to limit h tends to 0 2h divided by h into 1 minus x into 1 minus x minus h. So this h and h cancel, you see over here h and h cancel, this h term cancel with this h. So we obtain derivative of the function limit h tends to 0 2 divided by 1 minus x into 1 minus x minus h. Now putting the value of the limit h tends to 0, putting h is equal to 0, just you see over here in this term, putting h is equal to 0, this term will be 0, and simply we obtain the derivative of the function is equal to 2 divided by 1 minus x into 1 minus x, and 1 minus x into 1 minus x, we obtain derivative of the function is equal to 2 divided by 1 minus x whole square. So dear student, the conclusion of this lecture is how to calculate the derivative of a function by using the derivative by definition formula. This is the derivative by definition formula. In this formula you see over here, we just put two terms. Put the value of f of x, which is already given in the problem, and obtain the value of f of x, x plus h, from the given function. How we can obtain the value of f of x plus h from the given function? You just replace x from the given function by x plus h, like you see over here in this problem. This is the f of x is equal to x square plus 1. Now replace this x by x plus h in the given function. You can easily obtain the value of f of x plus h, and then put these two values, f of x value and f of x plus h value, in this formula. And before applying the limit, first of all simplify the expressions, like you see over here. If we put limit into 0 in this step, you see over here, x square plus 1 minus x square minus 1 will be 0, and divide by 0. So this expression will be 0 by 0 form. So before applying the limit, first of all define this 0 by 0 form, because this is the derivative of the function. If the limit exists, then the function will be differentiable. So before applying the limit, first of all define this undefined limit by using any simplifications. So after simplifications, then we put the limit value, then the derivative of the function will be defined and the limit will be exist. So dear student, inshallah in the next coming video we will discuss the derivative by using rule of derivative, like power rule, quotient rule, product rule, and chain rule. Now this is the end of this segment. Thank you. Allah Hafiz.